In the last video, we set up Virtual KD with WinDebug Preview with a virtual machine set up with Windows 7. I know it's pretty old school, but that gives us a little bit of runway to learn new stuff with kernel exploitation. And in this video, we need to actually set up our own vulnerable kernel driver. And that is going to be the Haxis Extreme Vulnerable Driver, or HEVD. If you haven't checked out the last video, I mentioned that this is very similar to vulnserver.exe. If you're familiar with that, it's sort of a user land application where you can exploit it because it's intentionally vulnerable. It has software flaws and bugs that you can use to learn some binary exploitation techniques. HEVD is the very similar thing, but in that low-level Ring 0 kernel space world. So let's dive in. Before we dive into the video, here's a quick note from today's sponsor. Developers are constantly changing the digital landscape, but building secure software isn't always easy, especially in growing applications worked on across massive teams. Companies end up with mountains of code, and they have to make a choice: stay competitive or stay secure. But with Snyk, you don't have to choose. Snyk helps bake security into the software development lifecycle. Snyk helps you scale and streamline by automatically scanning your code, dependencies, containers, and configuration files, finding and fixing vulnerabilities in real time. And it is super easy to use. You can sign up for free with my link below, import your repositories, and there, Snyk just finds your vulnerabilities. You can fix all these issues with just a single click. Snyk automatically opens a fixing pull request so you can just merge them into your repository and move on. And it fits seamlessly into all of your existing tools: IDEs, the command line, CI/CD pipelines, cloud infrastructure, and more. Millions of developers love Snyk, and you can see for yourself. Get started for free with my link below and develop fast and stay secure with Snyk. I have Virtual KD Redux running out of that vmmon64.exe on my host machine, and I also have my Win7 debuggy virtual machine ready for us. If you remember, we were using this to be able to hook in to the start of our virtual machine. Now, you might not always want to do that, or at least you might not always want to have it break as the machine starts up, especially if you end up rebooting multiple times because you've maybe hit a blue screen or you're just trying to refine and craft your exploit. So let me tell you that over here on the bottom left, you can click on that debug breakpoint on start and turn that off. Go ahead and click on that checkbox so that is no longer checked, and you could still have the debugger start automatically or not, or whatever you want, and you can run the debugger at any point if you really want to. But anyway, let's go ahead and start up our Win7 debuggy because we now need to go ahead and install our own HEVD or vulnerable kernel driver. Remember, it is good to get into the habit of hitting F8 and then using your up arrow key twice so you can disable driver signature enforcement as you start up your vulnerable virtual machine. Now, it's not vulnerable yet, right? But I think, hey, using that as just sort of a quick muscle memory, you'll notice that our Windows debugger or WinDebag pops up for us. But again, we don't need to be too concerned with it. It is not going to break at this point because we disabled that, and we should see our Win7 virtual machine start to boot nice and easy for us. I don't know if you can check that is a little bit of a faster startup time. Again, Virtual KD is trying to speed things along so that we can get right into the action. With that said, I do have one thing that gets in the way for me. As this machine starts up, it always prompts us for a password. So one thing that I do want to do in this video is at least add some quick registry tweaks so it'll just bring us right to our desktop and not have us enter the password every single time as we are refining our own exploit here. See exactly what I mean? Here it prompts me for a password as I log in. We can make that quick registry change at the very end of the video. I think let's get to the real meat and potatoes and let's actually get HEVD installed and set up for us. And now that we are logged into our Windows 7 virtual machine, we can fire up our internet browser to go download and install our HEVD. Offline, while I was not recording, I had gone ahead and installed Google Chrome so we can browse the internet without Internet Explorer 8 getting in our way. And let's go ahead and simply Google HEVD GitHub. And now we should be able to find, we do have a Haxis Extreme vulnerable Windows driver present on GitHub from the Haxis team. Let's go ahead and check out that repository. And here it is. Here are all the details for the Haxis Extreme vulnerable driver. It is an intentionally vulnerable Windows driver developed for security enthusiasts to learn and polish their exploitation skills at the kernel level. It's full of different vulnerabilities, from a simple stack-based buffer overflow to complex use after free heap exploitation stuff, pool buffer overflow, race conditions, and more. This was presented way back at Black Hat, even in 2016, and there are a ton of example resources or exploits or guides or articles that you might be able to use to learn something through this. There's tons of great stuff, and this is hopefully even just one resource. Please do not rely on strictly me to help you with your learning. Go check out all these other great guides and resources. Now, what we need to do is to either build the driver or just install one of the resources. You can see we could download just the binaries themselves, and it says if you do not want to build the Haxis Extreme Vulnerable driver from source, by installing Visual Studio and doing the driver kit, stuff that probably wouldn't work on Windows 7, hey, you can download the pre-built executables from the latest releases here. So let me go ahead and click into that to get to the releases tabs. And now I'm going to be targeting HEVD version 3.0. A whole lot of the previous guides that are available online are using HEVD 2.0. That's okay. Hey, we'll get a little bit more to explore or play with, and maybe we'll have to do some of our own due diligence to try and understand new stuff when things happen to go wrong or not quite our way. That's all right. Let's just go ahead and download HEVD 3.0. Check this out. We can go ahead and grab this. That should be in our downloads folder here. Let me see if I can extract all files here, and I'll bring this into just my user group and just call it, I suppose, HEVD. How about that? Great. Now, if you check this out, we have our driver folder, and there is a secure rendition of this driver and the vulnerable rendition of this driver. Obviously, for our learning, we want to go ahead and use the vulnerable driver, and because we're using a 64-bit architecture for our virtual machine, we'll use x64. You can see here is the hevd.sys and everything else that might be needed, including some symbols and the driver itself, right? So this is what we'll end up using, but you can't just double click on this. We need to set it up and install it, and we can use something like OSR tools to be able to get it loaded into our own machine here. Let me go do that. Let's go back to our web browser, and let's see if we can Google OSR tools. The OSR tools come from OSR Online, and this is one super duper cool space for everything related to Windows driver development. OSR has some pretty sweet stuff. If we wanted to scroll down, you could actually get into some other extensions for WinDebug. You could see other utilities that they put together. Some pretty cool stuff. I wonder if I can just look for OSR Loader. Let's just check out the downloads here. Oh, looks like I'm already on that page. It is worth noting here that these are no longer maintained and provided just for historic or archive purposes only. Most no longer serve a useful purpose and have been supplanted by standard Windows utilities. None represent best-in-class utilities or practices. And a big bold underline, well, just underline, we don't recommend that you download any of these US utilities. OSR is still doing some great stuff over on actualosr.com. If we move over to that page here, you can see the sweet stuff that they're up to. But I believe the real download that we want is honestly going to be present back on that other page. For now, OSR can do some contracting and other great things to build custom drivers, and that's kind of slick. Anyway, what we were looking for is the driver loader down here. It is a GUI-based tool for installing and starting your driver during the development process, and this is what we're looking for. You can check, hey, it's a little bit old, it's a little bit dated, but it should do everything that we need here. As you explore, there are some hiccups here. It does some strange stuff with the URL. So let's see if we can just go ahead and download the zip from this other multiple choice. And that downloads exactly what we need with the zip archive here. Now, if I show that in the folder here, I will be able to go ahead and extract this just as well. Let me go ahead and extract all files. And again, I'll go put this in my user profile and I'll call it OSR. Okay, now I'll be the first to admit, I don't exactly know everything that comes down in these subdirectories. Under projects and under OSR loader, you can see there's a kit, and then there are a bunch of these other things. I might be dumb, and I know that I am, but Win2K makes sense, like, ooh, Windows 2000, WLH, WNet, and WXP. I'm assuming that's Windows XP. Maybe one of these is supposed to be Vista. Maybe some of those are supposed to be another. Whatever. I'm going to go just making a guess at WLH. And we are going to be wanting an AMD 64 in this case. So let's go ahead and double click on that. FRE. Again, I don't know. Look, this is just seemingly what we'll try, and we'll see if we can pull this thing together. Let me see if I can run OSR loader just like this. We can hit yes, let this thing fire up, and check it out. Now we could go ahead and browse to our own driver that we want to end up loading. we'll go ahead and navigate back up to our own user account here. And where we've gone ahead and put our HEVD driver, go to vulnerable x64 and our HEVD.sys. We can work with this, and now the service start does need to be automatic. That is super duper important, so it's loaded as, automatically as our machine starts up. With that, we can go ahead and register the service. Pretty simple, A-OK, the operation completed successfully, and then we can go ahead and start the service. Let's try that. Okay, the operation completed successfully. Now let's go see what happens. Fingers crossed, this is everything that we needed to do. And now that that's complete, let's go ahead and just, shut down our machine. Before I take a snapshot, I do want to validate this actually worked and loaded for us. And now that the virtual machine is off, I am going to turn our virtual KD Redux VMmon 64. I'm going to turn that back to actually enabling the breakpoint as this machine starts up. That way we'll have a little bit of chance to be able to check out modules or things as we move through this, and maybe do whatever we need to do to add a little bit more nicety in working with our drivers. So again, I hit F8 as I start up this machine. You'll want to double arrow up to get to that disable driver signature enforcement, and then fingers crossed, we'll see WinDebug pop up for us. Perfect, looking good. Our machine is still waiting to be let go by the debugger, but you'll see, hey, we are connected to our Windows 7 target. Now, something that I think is super important to do, or at least worth a try, there is some sort of memory mask thing that the kernel allows you to experiment and play with to show debugging symbols or like output of drivers that might happen to be loaded. And this is something that, again, HEVD or vulnerable driver actually makes use of. So you can kind of see what's happening here and there. I gotta be honest, I haven't actually seen this thing come together to work. Maybe you'll have, your results may vary, but if we go into the command input here within our WinDebug, the syntax is ed, and I think that's edit. I got to review. NT with an exclamation point to refer to, hey, something that you're getting out of this sort of class, etc. Forgive me. I'll need to go ahead and check more of that syntax so it's not just pressing the I believe button. But that is ed, NT, bang, KD, being kernel driver, default mask, and that value should now be the number 8. If I hit enter on that, no output, but it is submitted. It is working just fine for us. And then I could go ahead and hit G to let this thing go. Cool. Debuggy is running. We'll see our Windows logo start to spin up. Windows 7 will go ahead and log in for us. And fingers crossed, I don't know if we're going to end up getting any output from HEVD as this thing is loaded and starting up, or that might be something that we either need to do ahead of time in a different place. I got to review this. But ultimately, we will do one last check to validate and see HEVD is loaded and running for us. That's all that we really need here. I will go ahead and log in. Okay, so I've kept this here now running over on my Windows 7 virtual machine. And I got a couple weird messages over in WinDebug, but I don't think that's anything to worry about. It's doing just what it needs to do here. If I go ahead and try to break, you'll see in the output of WinDebug that we are broken with a little int3 for the moment. Now, if I try to LM, I believe I can list modules that happen to be loaded. And this KD prompt, by the way, differs from what you might usually see in WinDebug. That is your kernel driver or kernel debugger thing. Think of that as you might. But LM should list modules. Now, there's a lot in here, but you might notice here is our HEVD. And super duper cool, if you wanted to even LM M referring to, I believe, the module, we can specify, hey, I only want to find HEVD. And there it is. You could browse the full module list kind of as we just listed previously with only the LM command, but HEVD, if I click in on this, it gives us a little bit more sweet stuff. We could check out the global symbols, the functions, other data that we might be interested in, but notice that it is loading properly the image path name here. So if I wanted to check out the functions that are present, it'll start to dump some of these. If I maybe wanted to explore what happens with a, H present. Oh, will it let me see these? Unable to enumerate user mode unloaded modules. Win32 error. 0N30. Ooh, I might be missing a step here. Let me go ahead and drag over some of the sweet notes that might be super duper helpful. Again, this is why I recommend even checking out everyone else's explanations on these. Look, I'm not an expert. I'm just trying to learn just as well. So huge shout out and thank you to Jeremy, who showcased a little bit of this, and fingers crossed we might get our answer in here. This was explaining setting up the environment, and he's using Windows 7 just as well. 32-bit in that case, using 3.0 for HEVD, WinDebug, IDA, OSR loader, everything that we've just done. And they were going ahead and spinning through OSR loader, IDA, everything they might be doing with some of these symbols here. That would be worthwhile too. I think we should go ahead and maybe grab and putting those and seeing where they might be able to retrieve those. They go ahead and create their virtual machine. They do a little bit more of the COM settings as they've done to do different things, especially with their own virtual machine to, do some of the baud settings for things that honestly Virtual KD has abstracted away for us. So again, huge shout out and thank you to Virtual KD Redux. And this might be a worthwhile point for us to look at. After you've made a successful connection between the debugger and the debuggy, you want to go ahead and check to see if you can enumerate the modules and HEVD. Now, querying the list of functions within HEVD, just as I've tried to do, well, we didn't get those symbols in there, so maybe it's not able to retrieve those. You'll note that I hadn't downloaded HEVD on my host, I only did it inside of the guest virtual machine. So let me go see if I can grab those releases and get the PDB symbol files just as well. I'll download this here. Let me put this into John H. HEVD. So ultimately, the reason that we probably wouldn't be able to see these symbols is because it's not in a location that WinDebug knows to look for it. Now, previously, again, in this guide, if you were to use this as a reference, probably a little bit better than just going through what I'm going through. But they note here that for HEVD 3.0, as we're using, if you actually put this in C:\projects under all this stuff, that will actually give you the location that it would need to be able to load those HEVD symbols. So let me go ahead and go do that. What I'm going to do is I'm going to create a directory inside of my C root of the file system here. I'll call this projects. And what I'm going to do is I'm going to paste in the HEVD zip archive, and let's extract everything here into this location under HEVD. There we go. So now if I move out, you can see in my path, projects, HEVD, build driver vulnerable x64, etc., etc., etc. HEVD driver. And one of those is actually different here. I believe it should be build. That is where we put this following. So let me go ahead and create another new folder. Build. If I spell that right, let's move driver into build. So that path is now projects HEVD build driver vulnerable, and our architecture is going to be x64, and HEVD.pdb is exactly where it should be. It does not have a HEVD subdirectory, so just for a sanity check, I do want to make sure that I can kind of create that and copy the PDB symbols file right into that directory. We'll go ahead and paste that there, just in case, because I don't want to have to figure out and finagle some of those. Now, theoretically, that should be situated. Let's go ahead and go back to our Windows 7 debuggy, let this thing start up, and we'll go ahead and disable driver enforcement with F8, hit the up arrow a few times so we can select that. This will kickstart our debugger, as you see present over here on the side. Let me go ahead and hit G to go, and now Win 7 should fire up. I'm going to go ahead and log in. And great, now our Win 7 is set up and running for us. Let me go back into the debugger and break here. And again, I'll try to search for our modules, list modules, specific module HEVD. If I go ahead and click on HEVD, we can see that we could again try to browse all global symbols or functions or data. Let me click on functions, and there we go. Perfect. Finally, we can see any specific function in whatever alphabetical name we might like. We could try to find like, buffer overflow or something. Here it is. Yeah, B, HEVD buffer overflow, stack IO control handler, all these other things that we might be able to go explore and play with. And we'll do that super duper soon in the next video. But now finally, we are all done setting up HEVD, and we know that it is loaded into our vulnerable virtual machine. Now we could go and exploit things, but I do want to speed up our workflow just a little bit. So let me let this machine go, and I'll go back to using our virtual machine. And now back in our Windows 7 virtual machine, I'm going to hit the Windows key and R so I get my little run dialog box. And I'm going to use netpl whiz, which should, fingers crossed, open up the old school user accounts. Super duper cool. So now this user, I want to see if I could go ahead and actually unclick this users must enter a username and password to use this computer. Now, if I hit apply, we can configure the automatic logon. We just need to specify the password that we use for this user. And then it will know to automatically log on this user every single time that we boot up the machine, right? So let me try to do that. I'll go ahead and restart. And that brings me right back to our boot menu. We'll go ahead and disable driver signature enforcement. VMmon might ideally catch this, but if it doesn't, we can go ahead and click on that run debugger button for us. And we no longer really need to debug breakpoint on start because we're going to automatically just get to our desktop when all the files and modules and kernel stuff should be loaded for us. I think that's just fine, and we can kind of speed up our workflow a little bit. Now we don't need to go ahead and stop and start this thing. It'll just automatically run here for us and should automatically log in. Perfect. As you can see, it does. We are automatically logged in and we can click around, do whatever we need. And of course, we can break with our debugger anytime we actually need to do something more or get to use our debugger. Again, can't use it in the virtual machine while it is caught by the debugger. But if I go ahead and hit go, we get to get right back into it. So this works great. We've sped up a little bit of the process and we have validated that the HEVD or Haxis Extreme Vulnerable Driver is in fact loaded, and we can check out the symbols. We can explore and do whatever we might want to. And really, we can start to exploit this thing in the next couple of videos. I think it's going to be a ton of fun, and that's when we're really going to get into the good stuff. But so thank you for bearing with me so far. I know I've already gone through a whole ton of rabbit holes and banged my head against the wall for a little bit, made a fool of myself, clearly demonstrating that I don't know what I'm doing, but we're going to learn together. If you're up for it, it's going to be a little bit of a journey and a wild ride. Again, I'm looking at this whole thing and man, I don't know if we're going to get through it all, but hopefully I can at least get a little bit of a kickstart and we get to jump in together. So thank you all for watching. I hope you enjoyed this video. We are all set with our environment finally after all that work. And now we can start to beat up the HEVD Haxis Extreme Vulnerable Driver. Hope you enjoyed this video. Hope you are following along. Please do all those YouTube algorithm things, like, comment, subscribe. You know the drill. I'm done. Thanks, everybody. See you in the next video.